Hey, and welcome back everybody. Another video here in the Dynaco Mark III restoration series at Blue Glow Electronics. Going to take a couple more steps today and try to get these at least one of these up and running here. What I'm working on right now, this is the little sheet that comes with the bias kit that you buy, which is not exactly the same as the original schematic. If you'll notice here, they use some 50 microfarad capacitors here and here, and on this this new one they've got some 100 microfarad capacitors in, and the original, you know, had the selenium rectifier right here, and the new one uses a diode bridge right here that on this little two-prong terminal lead that we put in. And so I've started basically installing this at this point in time, and I'm just kind of going through one at a time. All the yellow items here are highlighted, and that's all you have to install as part of the bias kit. Thus far, you can see here I've added the 0.02 capacitor right here, this 100 microfarad capacitor right here, and I've installed the 4700 ohm resistor right here. One thing, it's kind of hard, might be hard to see or tell right here on the leads of these wires, but I'm using Teflon wire wrap. It's pretty small stuff, and it slides right over the leads, and I pretty much take that all the way right up to the ends, so that if for some reason something got touched in there, that's insulated. Even though it looks like wire, it's actually insulated at this point with the Teflon wire covering. And I'd say the other thing I've installed right here, a little bit hard to see, but I've got the diode in here. It's a 1 in 4007 most likely. And we're just going to keep working through this list, and I'll show you as I get some of it done along the way. Okay, one thing I thought I'd point out to you, getting ready to install this capacitor, which in the case of this one is a 100 microfarad capacitor. If you notice in this diagram, the positive side comes over here and grounds on the tube socket. And the same here in the original diagram, this one, the positive lead comes over and grounds to the tube socket. Well, the original Dynaco tube sockets actually had some little ground lugs. You can see them 1, 2, 3, 4, 5. There are 4 around on each side of these things. So you're going to need a place to connect to. And these newer tube sockets, pull this out. If you'll notice right here, don't have a ground lug anywhere around on them to actually solder to. So there's a simple solution for that. You get these little tabs like this that they're kind of angled on one end, and that's actually 2 of them together. I can get them apart here. But you can see there's just little tabs, and what I'm going to do is I'm going to take the bolt loose right here. And I'm going to drop this tab down on here, and then I'll put the bolt back over on top of it and tighten it down. And then I've got a nice little place with 2 holes here to actually solder to. And I'll probably end up having to do the same thing on this other one for a few solder points that need to take place. Alright, and I'll see if I can zoom in on it. But yeah, but you can see here now that I've got this little ground lug installed, and can solder to that and got a nice little ground spot. Okay, we got this capacitor soldered in. This is a great example of where this Teflon wire coating right here going down and on this side is a really good place to protect this wire. Let me give you an example. Let's say someone bumped this capacitor and moved it this direction. What's going to happen is this wire here is going to go down and short on the chassis of this potentiometer, or if somebody just pushed down right there, they could push that wire right into that potentiometer. So dressing your wires is a very important safety feature, as well as it just makes the overall aesthetics of the amp look better. Okay, as I'm going through the diagrams here, either this one or the larger original factory one, the only other device outside of wires that haven't been ran yet is really this 680 ohm resistor right here that goes between terminal number 1, which is ground here coming out. If you'll notice the black transformer wire on the output transformer comes to it. There's also a wire then that takes it over here to lug number 2, which, by the way, lug number 2, if you can see it right here, is actually a grounded lug, bolted to this part goes all the way down, is bolted to the chassis. So it's grounded at that point, and there's a 680 ohm resistor here that goes across over to pin number 4, which is the yellow 16 ohm tap. And then from that point, there's a wire that goes from pin number 4 here, or terminal number 4, over here to pin number 7 on your driver board. And what this is your global feedback loop. So it's taking a sampling of the signal here, and it's sending it back here. And what this 680 ohm resistor is right here, that's what that is. You notice you're coming out of the output, kind of coming up, coming over. 680 ohms going to ground, the same as going to the common right here. It's ground. And it's a little bit of a voltage divider between this 1000K or 1K resistor and 680 to determine how much it lets feed back. And if you notice, then it feeds all the way back around over here and feeds into the grids here, or I mean the cathodes on the front end here. So and there's a capacitor as part of this this feedback loop as well. But I just wanted you to understand what that resistor was that we've added in. So I've kind of mounted it here. You can see it's strapped onto the ground lug here, and it goes over and ties off on the pin number, or the terminal strip number 4. I've not yet ran the wire from there over to here yet. I've still got a few wires to run in here, but I was trying to get all the components actually in the device at this point in time. Alright, I did realize one more component here. This 11.2 ohm resistor, and this is Dynaco picked this resistor very specifically here because it is actually the bias on the cathodes of these two KT88 output tubes. If you take a look on the schematic here, you can see here the two cathodes are tied together, and then they are tied right here 11.2 ohms to ground. And then if you'll notice, it says right here 1.56 volts. Well, the way this actually ends up working, if you can see here, is you've got this 11.2 going to ground on one end. The other end, it's going to the cathode of these tubes. And by the way, we'll tie the cathode of that tube to the cathode of this tube. So the two cathodes will be tied together here. And then there's a wire that goes from here all the way up and around right here to a pin on the front of the power socket. And this preamp power supply, then there's actually a spot marked here on the front of the chassis, as you can see. I'll flip this over right here, and it'll tell you right here it's kind of hard to see, 1.56 volts on this pin right here. So basically all you have to do is ground one end of your voltmeter somewhere on the chassis, stick the other end into this pin, and then you basically adjust the potentiometer back here, which you get to from the top, until you have 1.56 volts exactly right here across this resistor, basically. Well, I made a big assumption that that the bias kit would have came with the 11.2 ohm resistors, and guess what? I was wrong. So this is what they look like. It actually says 11.2 on it, and then at 1%. And I went back and grabbed two out of the existing amplifiers that we had, that I took these out of, and I went and measured them, and they both measure out at 11.2 ohms. So they're both still good. These are good quality resistors at 1%. So we're just going to use the ones from the old vintage amplifier in here. I think it'll give it a little bit of character to have some, apart from the original unit, other than the transformers and the choke. But yeah, that'll make it fun. Okay. I'm now starting to go through the book because I've got all the components in place. I'm just kind of coming back through the book and doing all the things that it says right here, because there's some things here if you just follow the pictures, it's easy to miss. So I'll give you an example. The second one right here says use a short piece of wire to connect pin V1 on V2 to pin 8 on V2, and then repeat this on step V1 socket. Well, this is V2, this is V1, and what they're really asking you to do is to connect pin 1 and 8. Pin 1's an unused pin, so you're really just tying these two together for use usage. And what I like to use here, let me see if I can zoom in a little bit on it. It's just a little piece of a wire I bent, basically ends of diodes and resistors, things that I've cut off. Just little pieces of wire like this is what I'm bending, and I'm just inserting that and bending it a little bit so that it'll go in between these two. Let me move that in here, and you can see here I've got it going between pin 1 and 8. I'll solder both ends in and snip the ends off. And so it's easy, little stuff like that you would never see on the picture. So make sure you follow all the steps in the book as well. Alright, I've picked a single strip here. I've got 25 feet of number 22 gauge PTFE silicon coated, or PTFE silicon coated silver wire. So I'm going to use this for all the hookups that it's telling me to do. And if you notice, the third one on the list here was, let me get my finger in here, connect an insulated wire from pin 8 on V1 to pin 8 on V2, solder this in place. So basically you're connecting the two cathodes together here on this. So I'm going to use this throughout the same color. It's kind of a purple and black and white. I like the look of it. I'm going to use it throughout the amp for hookups. Okay, so what I've done now is I've connected a wire here between kind of pins 8 here, you can see, and pin 8 over here, tied the two cathodes together. I've tied pins 8 and 1 together, 8 and 1 together. Keep in mind, pin 1's an unused pin, so it just gives you, by connecting those two together, gives you more stuff to connect to actually pin 8. And so this 11.2 ohm resistor needs to connect to pin 8, but since we've tied 8 and 1 together, you can actually connect it to pin 1. And what I did then is, you can see I mounted a ground, one of those little ground tabs here, because originally in the schematic it actually had the 11.2 ohm resistor here coming from pin 1 here all the way over to a ground lug on the capacitor here. As you can see, well, we don't have a ground lug on the capacitor over here any longer because we've replaced the capacitor with a capacitor board. So I just need to tie it to the ground, which was the same thing as the ground lug on the capacitor. So tied it right here, and then the other thing I've gone in and done now, just to be sure, I measured these two here together to make sure. Let me see if I can hold these on there, and you can see here 11.2, 11.3 ohms. So it's right there within spec at the 11.2. Even at 1%, it can be 11.3. So. Alright, let's dive in and keep going down this list here. Okay, up next, what I've done is I've rounded, the next line item here said basically connect an insulated wire from pin 8 on V1, so pin 8 here, around to around to pin 8 of the preamplifier power socket. So this is the preamplifier power socket, and pin 8 happens to be right here. Otherwise right here. And what I've done is I've run a wire all the way down, around, nice and neat, tucked. And now what I want to do is I just want to hit ground over here somewhere, and I want to hit pin 8 of this socket here, and then I want to see what we end up with on the voltmeter here. And I might have to slide this down, but as you can see, what have we got there? 11.2 ohms, exactly what we're supposed to have. And so that's how you're going to end up measuring your bias at the end of the day. Okay, good thing I'm going down this little checklist here, because you get to number 6 here, and it tells you basically right here, connect a 1000 ohm resistor from pins 5 on V2 to pin 6 on V2. And then you do the same thing, connect a 1000 ohm resistor from pin 5 on V1 to pin 6 on V1. So between 5 and 6 on both V1 and V2. And it says make the resistor leads short. So I went and dug up two 1000 ohm. These are 1% resistors. And we're just going to have to go between pins 5 and 6 right here on both these tube sockets and get those soldered in. Okay, we got the two resistors now soldered in, as you can see, between 5 and 6 on each of the V1 and V2. And I'm down to this next line here that basically says connect a piece of insulated wire directly from the condenser lug 1, which is the capacitor, to pin 8 on V3, which is the cathode of V3, which is the 5AR4. So this is V3 over here, and if you kind of look, pin 8 is going to be right there, which is cathode. And what it's saying to do is connect a wire straight from there to the condenser lug 1, which would be right here. Well, we don't have a condenser in place. You can see here they'd actually run a wire straight from right here on number 8 down to number 1. Well, remember we chose not to use the little capacitor. Instead, we decided to use an upgraded the SDS board, which is right here. And let me back up just a hair here. Let me talk to you a little bit about what this board really is, okay? What you've got here is this whole side is ground, as you can see here. So basically you have a connection to this side of the capacitor, here, here, here. And then the other side of the capacitor is then connected to another capacitor here. So you're kind of coming off the negative, and then the positive here is connecting to the negative of another capacitor, and then which is then feeding over to the positive side, which is coming up to here. Same thing here, same thing here. So what you kind of have is four separate individual sections right here of capacitors. So it's like these two are tied together, these two are tied together, these two are tied together, these two are tied together. And so if you actually take and look at the little schematic that they provided here, let me zoom in on it a little bit, and it's what it'll tell you right here is these lugs right here, there's two sets of them here. You can either connect to a power transformer B+ winding right here, which would be this yellow wire right here. And what you would do is you'd put two diodes right here, bypassing the 5AR4. Well, I'm not a huge fan of solid state power supplies and tube amplifiers because they come on instantly, heat up the tubes instantly. Before they've had a chance to warm up, you're applying voltage to the tubes, and it just kind of decreases the overall life of the tube. So this thing gives you some flexibility. I'm a fan of using the 5AR4 here for your rectification instead of the two diodes you would put right here. So it gives you that option. It says or, put the cathode right here, okay? And then what you end up connecting here and here is the choke leads that would have normally come back here to the original schematic. The choke leads would have, let's see here, choke leads would have fed out right here, around, and came over here. One pin would have went to number 8. The other pin here would have gone to section number 2 right here in the capacitor. So same gig. We're going to go to pin 8, which is part of section number 1 here, and then the other one's going to go to part of section number 2 right here. It also tells you that in this spot you need to connect the output transformer center tap. No different than the red wire that comes out of the transformer, feeds all the way around over here and would have fed to that same location. So basically, this little board is the same as that capacitor. And then you'll connect one pin 5 here. You'll come back down here on the board itself, and you will find pin 5 wherever it's at right here. And then you'll connect pin 6 right here, all the way over, and connect to pin 6 right here. So pretty simple setup. We just got to go through the steps now of mounting this. If you remember earlier when we were doing the let me back up a bit. When we were doing earlier, we had this one wire left over. Well, that's the wire that's going to end up going to this board where it said the center tap of the output transformer, which will actually end up going right into this place right here. So I'm probably going to feed these honestly in from the top down and get this thing mounted and just solder them in place that way. So I'm going to get this mounted. I don't know if you noticed here, but I've already put in the 2 longer screw bolts right here and right back here. They showed up in the mail, and I'll show you the comparison. This is what I had in there at one point in time, and this is the longer one now that we're using. So it's about twice as long, and it gives me enough room to actually put another bolt on top of this as a standoff and then drop the board down on top of that. Okay, check it out. We have now mounted, we put another screw on each side here, or nut. We dropped the board down in tight on both sides, and then we put another screw on top right here to hold this down, and it is, as you can see, it's solid as a rock. Looks beautiful sitting in here. I mean, that's as clean as can be. And I made sure I kept this red wire out from underneath of it, because we're actually going to have to end up feeding it in and soldering it in from the top side here. But yeah, I couldn't be any happier with how this thing actually turned out. Okay, we've got our wire now from pin 8, the cathode of the rectifier, feeding around, down under, kind of snaked it around, and brought it right over here and soldered it into the first lug. Just like it shows here on the schematic, that goes to the cathode of the 5AR4 right there. Okay, the last two lines here. Connect a piece of insulated wire from condenser lug 1 to pin 8 of V3. And connect one lead of the choke to pin 8 on V3 and the other lead of condenser to lug 2. So, what that really translates to in this new board here is you connect the choke from here to here, from these two sets to these two sets, because you've already connected this one to pin 8 of the 5AR4. Then the other thing you're going to do is bring out the red center tap transformer wire and plug it in here in these as well. And at this time we have got all that done. The red center wire comes out of the transformer, comes up here and goes into this set. One black wire of the choke goes here, one black wire of the choke goes here. This striped wire feeds all the way around. And as you can see, it goes to pin 8 of the cathode here. So a little different layout than the original board, the original plans here, but if you study it a little bit, you'll figure it out and can make the substitution. This whole board here is pretty much equal to the little can capacitor. Okay, still going through it, and I just realized here that I had missed a step back on the connecting the transformer wires. It basically said cut off 2 pieces of 5-inch insulated wire, connect one end to pin 2 of V2, connect the other wire to pin 7 on V2. These two wires, twist these two wires together and connect free one end of pin 1 of V2 and the second wire of V2. So basically what you're doing is connecting V1 and V2 together owns pin 2 and 7. And really what that is, you see right here, this is the big heater wires that feed AC to the heaters of the KT88s here. So what you're doing then is you're putting another set of wires together, twisting them together, and running them down and connecting them together here. And I always like to use green wire when I'm connecting heaters together. It's just kind of a universal symbol within amplifiers for filament or heater wiring. Okay, we've ran a wire from terminal 3 here over to, which by the way is on the is part of the power supply for the bias. We've run a line all the way over here to, oops, can't see it, to terminal number 3 here on the potentiometer. So that's what's actually feeding the voltage to this potentiometer. And then coming out of this is really the balance, which feeds the the bias on these two tubes. And then adjusting this, adjust the amount of basically plate current and or cathode current, and when you get the right amount, you can read it off here on the front at 1.56 volts across that 11.2 ohm resistor. Okay, I'm reading a section here now, going through it, called Connecting the Printed Circuit Board, and it just talks to you a little bit about how to solder properly first. And then it says the connections to the board as follows. Connect the insulated wire from potentiometer lug 2 to eyelet 2. Okay, so what they're saying is, for potentiometer lug number 2 right here, we need to connect a wire over here to number 2. Except for this board's a little different. It has a 2A and a 2B right here. And so what did I do? I went and pulled out the book for these amplifiers, and if you'll notice, where is it at? Right here. It says, let me zoom in a little bit more here. Maybe you can read it with me. It's basically saying here, Note that all outlets and pad numbers on the conversion board correspond to the original Dynaco outlet numbers. 2 outlets were changed on the conversion board, 2A and 2B. This is to facilitate the addition of separate bias controls for each tube. If you do not wish to do this, jumper pins 2A and 2B together, and then just basically put the wire from outlet 2 to either in A or B. So since we don't have a separate bias set up per front end tube here, we're going to keep the kind of factory bias. What we're going to do is we're going to jumper these two together right here, and I'm going to flip it over, and there's a little place right here where I can jumper together, and then we'll feed into one of these coming off of this second pin right down here. And if you remember earlier, I showed you how to make a jumper here. You just grab a little piece of resistor wire, lead, or something that you've cut off at some point in time. Grab your pliers, kind of like this, put it in on one side, put it on the other, bend it over good, and all of a sudden you've got yourself a nice little jumper. And then we can take this and we can drop it down into these 2 little holes right here. And, oops, I got it a little too far apart there. Good news is you can take your pliers here, straighten it right back out, get a little closer, bend it down, drop one in, oops, drop the other in, right down there. Got a nice little jumper in place. I just need to now come along with some really fine solder like this, and solder these 2 tips, or solder these 2 ends of the jumper right in place. We're good to go. Now that ties this whole 2 sections here together, so we can just feed from the potentiometer here over into either one of those sockets at this point. Alright, you can see the wire here. Kind of feeding from pin 2 here, wrapping around over here, coming over here into pin 2. Alright, next up, connect the wire from pin 6 on V1 to outlet 1. So we came from pin 6 right here down to outlet 1 right down here, and we have soldered in our little wire. And the same thing here, pin 6 down to number 3 here on the board. Okay, up next was, we told us to come from pin 4 of V2, which is right here where the green wire's connected, over to pin number 4, socket number 4 here. And also I had to run one over here from basically the 16 ohm tap down to number 7 right here. We've got those in place. Okay, up next, if you read the original instructions now, it's talking about connecting from the condenser or capacitor to outlet 5 and outlet 6. But since we're using this SDS board here, and let me zoom it out just a little bit so you can see better. You know, it talks about connecting pin 5 to right here and pin 6 to right here. So really what we've got to do is now run from here over to, this would be with pin number 5. So we would run from here over to number 5, which I've got to find right here. And then we would run from right here over to pin number 6, which is right here. So pretty short little runs from here to here. Alright, well, got a couple more things connected. Pin 5 here, over here, just like it showed. And pin 6 here. And I made a mistake. I realized this just a second ago. If you read it, it goes over here, and what I thought I was connecting to pin 6 is not. That is pin 9. It just looks like an upside down 6. This is actually pin 6, so I've got to unsolder that and put it back over here. Because this is 8 and 9 together, and what you'll end up doing next is we'll end up coming off of these 2 pins right here with the heater wires, and we'll end up creating another set of twisted heater wires and feeding over here into pins 8 and 9. It's kind of where this is 6 volts, and you're feeding the KT88s this, and then you're going to feed the tubes themselves. And now if you notice, I'm coming from here going over here to which is pin 6, and I do think real quick, because I've sealed up 9 here, it would make sense if I can find it here under my pile of 1 million things. There it is. I do think it makes sense to come along and use the little solder sucker on this hole and get it opened back up properly, so that it may take a few times here to get all that out. That way it'll be easy to kind of put the, there we go. Now we got our hole again in there we can work with. Alright, you can see here pins 2 and 7. We've got the green twisted wire all the way up feeding into holes 9 and 8 right here. So we've got the heater wires to feed the tubes on both sides of this little preamp board. Alright, we've done a few more things here. Pin 10 on this board, you run a wire up to the center conductor of the input RCA jack, and pin 11 here goes to the outer connector here. And one more thing I was going to show you. The next step we're about to do is to actually run the power cord in. It comes in right here. There's a 3/8 inch hole here on the front of the chassis, you can see. And we'll put a grommet in there, or what's the right word for it? A Heiko or strain relief plug right there. But one thing we're going to do that the original Dynacos did not do is we're going to have 3 wires now instead of 2 in the power cord we're going to use. So we're going to need a little grounding lug here, much like we've used before. And I'm going to put that grounding lug right here on this transformer bolt. And what that'll do is let us give us a place to tie the ground off to from the power cord. And the other 2 connections, the white one will end up going right here to the fuse, and the black one will end up going right here onto the power switch itself. So stay tuned and I'll go get a power cord and we'll do that. Okay, we're down to just a few things at this point left. Power cord, and if you'll notice here, this is just a standard what they call IEC power cord. 3 prongs on one end, the other end kind of plugs in. Well, we don't have the ability to put an IEC jack into this this amplifier, so what we're going to do is we're basically going to take it right here on this end and we're going to cut this thing off, and that goes in the garbage. So now what you got is 3-prong cord on one end and the other end cut here, and we're going to have to show you how to strip this here in a second. But what's important, I was going to tell you, I picked these things up. You can get them on eBay, a pack of 20 of them for about $20, so $1 a piece. But if you don't want to order some and you need 1 or 2, easiest place to find them is Goodwill. Goodwill always has a little section on some end cap where they have computer cords and mouse cables, and USB cables, etc. And they're just they're there for usually $1 or $2 a piece, so you can pick some up there if you need them. I'll show you how to strip this in a minute, but first I want to show you, you're going to have to use a strain relief little device. These things are usually about 50 cents or so. The way they work, they kind of go around the cable, and then the other side here comes around and it pushes down in, and it squeezes the cable together really good. And I've got a special tool that's made by Heiko to squeeze these things together, and then you end up pushing it into the socket here. So this little 3/8 inch socket, this thing here will end up pushing into it and locking the cable in really tight, nice and tightly. One thing you want to look for in these when you buy one, there's 2 different kinds. Oh, hey Waffles, you want to come say hey? Oh, Waffles says hey. She's my weenie dog here. Tell him hey again. Oh, she don't want to. Anyway, these this little end right here if there's two different types. If it's made for a round power cord, this little part right here will be curved and round. If it is made for an older flat style cord, like a two cable cord, that little piece right there will be flat. So make sure you're using the right kind. Hopefully you can see that that's rounded there when you're going to put this thing in. And one other thing I want to put in line that Dynaco did not have in their instructions anywhere, but I'm going to put a thermistor in line with the power cord. This is a CL80, and you can get these. They're usually about $2 or $3 a piece, something like that if you buy them in quantity. If you don't, they're more like $4 or $5 a piece. But they serve two purposes. The first purpose they serve is that they kind of slow down the inrush of current coming into the amplifier, so helps with the tubes warming up, etc., not get such a big inrush of current all at one time. And then the second thing that they do, as a byproduct of that, they actually drop the voltage. It's a little bit. It's actually a thermal resistor. Drops the voltage by a volt or so. So helps out a little bit with the modern line voltages and reducing those. So I always put those in, but it's mainly for the slow power startup there. You don't get this huge inrush of current to all your components when you first flick the power switch on your device. Let me get out my stripping stuff here, and I'll show you how to do this. Okay, a couple things about stripping these cables. One, do not mount the cable in the device first and then end up trying to strip this thing. You just chew your fingers up and you're kind of working in a tight space, whereas here you got this thing out, you can strip it and then you can still feed it in there and lock it down without that. You got to realize too, you're dealing with 3 wires with, you can see here, 3 wires with their own shielding inside of a bigger, blacker outer sheath. So I kind of like to take something, and you can either use an X-Acto knife or you can use the cutting blades here or something. But you just want to start, leave yourself enough cord out here, and you want to start working your way around. But what you've got to be very, very careful of is that you do not cut down and go inside and cut the inner sheath of either the white, the green, or the black wire. You may even actually be better off if you're not sure of yourself and what you're doing here, and getting a knife and starting here on one end, a sharp razor knife, and cutting this way down the cord from your starting place, because at that point, you know, you're less likely to cut cross-sectional into any of these wires, and you can kind of work with this and get it opened up. But what you don't want to do is cut across this way down inside and get into the next layer of wires, because especially if you do it back here, because then you're going to get done, you're going to have stripped wires, but you're going to have cut in the inner insulation right here, and you're going to have cutting this off and kind of back here and starting all over again. So yeah, you just have to spend a little time with this thing. If you start down here on one end and get cut all the way through like that, then you can kind of get in here a little bit and start pulling these wires out like this. And then usually if you've made a little strip down there, look at that, it pulls all the way down. And then you can take an X-Acto knife, or like this case, a razor knife, and you can go down here and cut around here and cut this off. But never once did I cut down in and get into these wires in this direction. And the good thing is most of these wires are going to get cut off, so if I did happen to get into some of the insulation down here, it's no big deal. But this one's actually looking really good. I'm going to find a way here to kind of cut down in through here very gently and not get into the next layer there. And lo and behold, look at there, we've got the ends ready to go. That's enough to work with on the inside here. I've got the 3 wires, and then once you can kind of strip the ends off here like this as well before you get going inside of that thing. But you may need to end up, once you get them mounted, cutting them shorter anyway, so you can do it on either side. But at this point now, you would kind of put this thing in place, come around here, lock this, use the tool I'm talking about, and I'll show you that in a minute. Okay, up next, pretty cool tool here. It's got a little ratchet action to it, but mainly what it is, it's the offset that helps, because you actually end up taking this little device like this, putting it on here, you bend this thing around, you get this up here, and then what it's got to do is it's got to close down in and squeeze around this cord, except for I got to get it going the other direction. just like such. And then you're going to want to leave a little bit on the other side here on the inside of the amp. But the way this pliers work is it lets you grab this from the side here like such, and it lets you squeeze these things together like so. And once you get them squeezed together like that, then you can turn it around, you can hold this up, kind of stick this into the amp at that point in time, and lo and behold, get it grasped back on there good. Squeeze it all the way in. There we go. And you can push that in, and it is now locked in place. I can't pull it out. And you can see the other side here, nice and neat. Let you look at it here, what I did. So you can see how they're locked in on one side now, and you can see where that thing's squeezed together. And on the other side, it's locked in now, and there is no pulling this thing out at that point, and we've got our wires down here now to solder to. One thing you may wonder is, why did I not put this power cord on a long time ago? I always put these on very last. I'm telling you, it's just in your way constantly. As you're spinning the amp, as you're trying to move it on the bench, you got this thing falling off in your lap. It's the very last thing you ever want to put in when you get the amplifier complete. And hey, good news, I haven't said that yet, but we are complete with this amplifier. I do have one question. I went through the instructions here, and nowhere on here, if you'll notice, does it show to connect anything on this side to ground. But after studying the back side of this thing, this is the ground plane here. So my assumption is that you would take and connect a wire from this here on the back side, like maybe right here, this one right here, and you would tie it off to a tab somewhere like this one down here, and have it tied to ground. But nowhere does the instructions, I actually read through the written part of the instructions as well, nowhere does it say that. So I've actually shot an email off to this guy here, Sheldon Stokes, to ask him a question, just to make sure before, maybe I'm missing something, but I'm a firm believer that thing needs to be grounded on that side. And it's weird because the bolts themselves don't ground. If you'll notice here where it mounts on either side, it doesn't even connect to the ground plane, so it's not like the bolts are actually grounding it down when you mount the thing. So I'm about positive that's got to be grounded like 99.999%. But the fact the instructions didn't say it and did not call it out, I'm just waiting on his email to come back just to validate my my crazy line of thinking right now. Okay, let me show you what I've done at this point. The white wire, I brought it in, I stripped it off, soldered it right here onto the other side of the fuse holder. The green wire, as you can see, it comes in, kind of goes down. I soldered it well here to the ground lug. The black wire, I brought it around, but first I soldered one end of this thermistor onto, right here, the center lug of the power switch really well. And then the other end, I bent at a 90-degree angle, and I soldered the black end here onto it, and I had slid a piece of heat shrink tubing up on this black wire first, pulled it back down, and heat shrunk it on there, just so there's no exposed wires right in here. And if you'll notice this, this thermistor here, I'm going to push it away from this capacitor a little bit. Don't want it to get too close to it because it will generate heat. But the good thing is I've got it sitting in a place that can generate heat, and actually it's going to go up into the transformer hole there, where there's a little bit of air that can go through there. But what you wouldn't want to do is lay that right on top of something, because those things do get pretty hot and stay hot while the unit is running. But it's nice and tucked out of the way, and nice clean wiring. At this point in time, with a few exceptions here of one, customer wants me to mount in a factory capacitor here. It's not going to be hooked up, but just for aesthetics, so that the top side of the amp doesn't have a big hole in it right there. I've got that to do. Now, I got to wait on this email back from Sheldon Stokes, but my guess is I'm going to end up grounding this hole right here, or one of these over here. I could tag that one off to ground as well. I think I'm done. I'm ready to drop tubes in it and bring it up with a variac and set bias and test it out, etc. I'm pretty excited at this point. This one goes well, and I'll sit it on one side of the bench over here. Oh, sorry about that. Yeah, we'll slide it to one side of the bench. I'll put the other one right here. Go through the same instructions, but at least I'll have another one to look right over at, and I'll make it look identical to this one. And maybe have both these done this weekend and get them back out to the customer. I'm going to go ahead and get this one posted since it's complete, this video. And then the next video, the final one, will be powering up, making sure everything's working, and assembling the second one. So we'll call it a wrap for today. Amp is done. Looks complete here. Flip it over here on the bench. Looks really great right now. Beautiful. You can see this board here. Let me zoom in on it a little bit. I mean, it turned out great. Everything looks good on it, even the wires coming through the other side. I have came along the way as I've kind of put wires through the other side, and I've kind of snipped off ends and make it nice and neat. Like right here's another one I need to kind of snip it off. You don't want wires sticking up through. And sometimes I'll touch up the solder joints, just make sure they look really good on this side as well. Thanks for watching, everybody. I know this might have been a little bit of a long one, but hey, just another video or so, and we'll be done with this whole series here. Thanks, and hope you have a good weekend.